Imagine sitting under the stars on a warm summer night, gazing up at the vast expanse of space. Now picture this serene moment interrupted by the sudden realization that a colossal asteroid, hurtling through the cosmos, could one day threaten life as we know it on Earth. This was the scenario astronomers faced when they discovered Apophis, a menacing space rock named after the Egyptian god of chaos and destruction. How did scientists discover this threat? How can we know its trajectory? And finally, what is our plan for planetary defense in case it turns on us? In June 2004, a trio of astronomers at the Kitt Peak National Observatory in Arizona stumbled upon a celestial intruder, a 340-meter asteroid ominously dubbed Apophis. Named after the ancient Egyptian god of chaos, this cosmic wanderer captured the attention of the world as astronomers initially deemed it a significant threat to Earth. However, as we'll soon discover, the story of Apophis is far more complex than its foreboding moniker suggests. When astronomers first laid eyes on Apophis, alarm bells rang across the scientific community. Initial calculations projected a concerning possibility. Apophis had a chance of colliding with Earth in 2029, sparking fears of potential devastation. This looming threat prompted a flurry of observations and analyses to assess the true risk posed by this cosmic interloper. However, as scientists delved deeper into Apophis's orbit and behavior, their understanding of its potential impact began to shift. Radar observation campaigns and precise orbit analysis provided invaluable insights, leading to a significant evolution in our understanding of Apophis's potential threat to Earth. By meticulously studying its path and behavior, scientists gained confidence in ruling out the possibility of an impact in the near future. With a clearer understanding of Apophis's trajectory and minimized impact risk, attention turned to its upcoming close encounter with Earth in 2029. This cosmic rendezvous is set to bring Apophis within a hair-raising distance of approximately 20,000 miles from our planet's surface. While this may seem like a considerable distance in astronomical terms, it's a remarkably close shave by celestial standards, offering a rare opportunity for astronomers and enthusiasts alike to witness the asteroid's passage through the night sky. As Apophis sweeps past Earth, those in the southern hemisphere will have a front-row seat to observe this celestial spectacle, as it traverses the skies above Australia, resembling a fleeting speck of light against the backdrop of the cosmos. With its closest approach poised to occur over the Atlantic Ocean, followed by a swift journey across the United States, the 2029 encounter promises to captivate stargazers worldwide with its awe-inspiring display. Amidst the grandeur of celestial events like Apophis's close flyby, there lurks a subtle yet potent force that silently shapes the destiny of asteroids traversing the cosmos. This force, known as the Yarkovsky effect, arises from the uneven heating of an asteroid's surface by the sun, leading to the emission of thermal radiation and the consequent exertion of a gentle but persistent force on the asteroid's orbit. As Apophis continues its celestial journey, this effect plays a crucial role in subtly shifting its orbit over time, potentially altering its trajectory and bringing it closer to or further from Earth with each passing year. Understanding the intricacies of the Yarkovsky effect offers valuable insights into the long-term dynamics of near-Earth objects, like Apophis, as it becomes increasingly clear that precise orbit analysis and impact risk assessment are paramount in safeguarding our planet from potential cosmic threats. Navigating the cosmic dance of celestial bodies requires a keen eye and a thorough understanding of orbital mechanics, especially when potential threats to our planet loom on the horizon. For Apophis, once deemed a significant hazard to Earth, a comprehensive impact risk assessment has yielded promising results, leading to its removal from the Sentry Risk Table. This table, maintained by NASA's Center for Near-Earth Object Studies, serves as a vigilant guardian against potential asteroid impacts, cataloging objects whose trajectories bring them alarmingly close to our planet. While Apophis's removal from the Sentry Risk Table offers a sigh of relief, it's imperative to grasp the potential threat posed by asteroids of similar magnitude and composition. Understanding the impact kinetics of these cosmic wanderers is key to gauging their destructive potential upon collision with Earth. Picture this: the colossal force unleashed upon impact, equivalent to over 1,000 megatons of TNT, or the destructive power of tens to hundreds of nuclear weapons. Such a cataclysmic event would wreak havoc on an unprecedented scale, causing widespread devastation and loss of life on a catastrophic level. The sheer kinetic energy unleashed by Apophis would be akin to the impacts that created landmarks like Meteor Crater in Arizona or the Tunguska event of 1908, but magnified exponentially. Imagine the horror of billions of lives hanging in the balance as Apophis hurtles towards Earth, threatening to unleash chaos and destruction on a scale never before seen in human history. Entire regions obliterated, cities reduced to rubble, and ecosystems thrown into disarray as the impact triggers tsunamis, earthquakes, and wildfires across the globe. The aftermath of such an apocalyptic scenario would be unimaginable, with millions, if not billions, of casualties and widespread devastation that would take years, if not decades, to recover from. As the specter of Apophis looms large on the horizon, the urgent need for robust planetary defense measures and global cooperation becomes all too clear. Only by uniting our efforts and harnessing the full extent of human ingenuity can we hope to avert this impending catastrophe and safeguard the future of our planet. Evacuation plans would need to be meticulously crafted, with designated safe zones identified and logistical challenges overcome. But beyond evacuation, the real focus would be on global cooperation to devise and deploy planetary defense strategies. This would involve a collaborative effort on an unprecedented scale, with nations pooling resources, expertise, and technology to develop innovative ways to deflect or mitigate the impact. Imagine teams of scientists and engineers from around the world working tirelessly to build spacecraft equipped with asteroid-deflecting capabilities or designing powerful laser systems to vaporize incoming debris. The urgency of the situation would drive humanity to set aside differences and work towards a common goal, protecting our planet and ensuring the survival of future generations. While the threat of an Apophis impact may have subsided for now, the need for continued vigilance and preparedness remains paramount. To learn more about NASA's plans and the latest developments regarding Apophis, be sure to check out the video on your screen. And if you are curious to see more of any of the subjects from these videos, leave it here in the comments and take the opportunity to like the video and subscribe to the channel for more videos like this.